to click on competitors' ads and try to get their ad bill, basically. Now Google has something where they complain, hey, someone's got a click car in India, and they're trying to run bill. So they've settled that now just on a case-by-case basis. Maybe they have an algorithm to kind of detect it. Google has to fight against this all the time. Try to gain the system, search, optimize the search. They're trying to, yeah. So they haven't been able to cut out human people. They still have to have a pool of experts to look at the situation. The machine goes, this is unusual. Like the machine, from what I understand, the machine, their algorithm will say like, hey, this situation looks like it could be fraudulent, but it's really unusual. I don't think this is usual. And they keep it over to they flag the machine learning algorithm tries to spot the obvious scams. So this is program recognize. It just shows them what happens. And then flag things with the view that they still have people on these things. It gets better. It gets better, but some of them are just situations where it could be legitimate or it may not be. You're always going to need people. But no. Just they can view the performance, right?
All right, we are going to get started. Thanks everyone for coming. This is San Barbara JavaScript meetup. Before we get started with Samir, just some quick shout outs to our sponsors. Number one, WorkZone for hosting, Agilysys for always getting us pizza and having a backup spot, and PayJunction, who is also one of our newest sponsors. They are going to provide hosting and food as well. And then also O'Reilly Media. We've got like a deal with them where we can get some tickets for discount. So that's about it. And without further ado, Samir, let's do web workers.
Thank you. My name is Samir Mirza. I'm a software engineer at SHP. We're a shop. So if anybody's looking for a job, talk about that. All right. So let's talk about web workers. So before we get into web workers, just a show of hands, how many of you are familiar with multi-threading? All right, so we're going to cover some multi-threading concepts first, and then just cover some low-level concepts before we go into web workers. So before we cover the multi part of it, let's talk about what a thread is. So basically a thread is, you can think of it like a software unit. Basically it has its own stack, its own memory to keep track of its own variables and that sort of stuff. And it has its own control flow. So it's the execution flow of your program. It's basically running your program step by step. You're declaring variables, you're calling a function, and it's all happening one at a time. And basically, whenever you launch a program, whenever you launch a process, the operating system creates a thread for your application, and then you have that one thread that manages your UI, drawing stuff on the screen, running your code, that sort of stuff. So here's just a simple flow of things. You start your program, you declare a variable, and you set some value on it, and then you perform some mathematical operations. But it's all happening one at a time. So you want to download a file, well, it's going to stop doing whatever it's doing, and it's going to focus on downloading this file. And it's done. Now, the event-based event loop application is a little bit different. Where
it's in a constant loop. Oh, we're getting feedback. so it's in a constant loop. That's good. But if no events are, oh, there we go. So
now you're doing two things at the same time. Either you're declaring a variable or you're adding stuff. So, sounds great, right? Sounds very powerful. You know, what could go wrong? Well, let's look at a pseudocode example. It's kind of like JavaScript, but it's not. So we're going to declare an array of users. And in this array we have 3 users. And the operating system starts this main thread. And let's say there's a delete button on this on your application. And whenever it's clicked, it calls back with what index it wants to remove, what item it wants to remove from the array. But it also starts a new thread called download users. And this goes and downloads a bunch of users from the server and comes back and wants to add these users to the array. So can anybody see what could potentially go wrong here if the user is actively So basically, you're going to hit a race condition. Download user is going to come back and it's going to try adding stuff to the array. And the user is clicking on things and trying to delete things, and you don't really know what's going on with the array. You don't know. Maybe the user deleted the last item, and at the same time, you have this the download users come back and try to add things. So things start to get a little complicated. And you basically get into the problems that come with multi-threading. And so here are some of the problems that happen with multi-threading. You have 2 threads trying to access the same resource, and big problems occur. You get race conditions, deadlocks, and it's not fun. You get very complicated very fast. So in order to solve these problems, what is typically done is basically lock access to a particular area of memory. And before any thread can access that area of memory, whether it's an array of users or variables, before that can happen, they have to acquire a lock, and then they get access to the memory location, and they can make their modifications, and when they're done, they release a lock. But if another thread comes along and tries to access that too, it has to acquire a lock. But if you already have a thread that has acquired a lock, the second thread has to wait until that lock is released before it can access that memory location. So great, right? Problem solved. And let's say we have two arrays. We have one array of users and another array of sorted users. And in order to sort the users, well, first you have to access the initial list of users, and then you can do your sorting and filtering, and then you can update your sorted users list, for example. And let's say you have another thread that, if somebody tries to delete something from sorted users, you also have to delete things from the original source, the original users array. So you have some threads that are trying to lock sorted users, and then they're also trying to lock an array of users, and then they'll release both locks. But then you have other threads that are trying to access the primary array of users. And that's how you get into deadlocking, where you have one array or one thread that's trying to access another memory location, but it's locked, and it currently has a first location lock, and it's trying to lock this, and then you have another thread that comes along that has a lock on this, but it's trying to get a lock on this, and basically nobody's going to release the other thread has a lock. Does that make sense? Those are the problems that come with multi-threading. One last thing we're going to do before we look at multi-threading in JavaScript. We're going to take a quick peek at the V8 engine and see what's going on. We're going to look at a hello world example in the V8 engine. This is some C++ code. And we're going to ignore a bunch of the stuff, and what we're going to actually focus on or pay attention to is the isolate. Can you guys see the back? Kind of, sort of. Let's see. Zoom. Oh, this is. Nope. Huh.
Propeller Plus, maybe?
What's showing? Visual Plus, yeah, that's. Okay, I tried it. We'll just explain it. We have some object called isolate. We don't know what it is yet. Another object called handle scope. We have another object called. Then we have our code portion of it, and we compile our code. And if we look at the code comments, basically, if we look at some of the definitions, this is from developer.google.com. I'll provide some links on the meetup later. But so an isolate is basically a VM instance with its own heap. So it has its own memory, has its own memory space, and local handle object is a pointer to an object, and all V8 objects are accessed through handles. And basically, if a handle is released, a garbage collector comes along and starts cleaning up things. So if you've ever, if you had a reference to an object literal in an array and you pop it off, the garbage collector will come along and release that, free up that memory space, because there's no handle attached to it. And then a handle scope is basically a container for any number of handles. And so when you exit a function's scope, for example, every handle in there gets released and gets garbage collected. Now, the most important part, or one of the most important parts, is the context. And this is basically your execution environment. And your context is attached to an isolate. And the isolate stores its memory. So whenever context is running your code and you try to create a new object literal, for example, the context executes that portion of the code, and the isolate provides a memory space for that. So that's kind of how the V8 engine works. So you have your isolate, and only one thread can access isolate. So, and it's the same thread that runs your, that provides execution for your context, which is running the code. Now, the other thing that also context creates or contains is the globals, like math and typical objects that come with the V8 engine, arrays, and so forth. Now, the same way document, in browsers, you have a browser that has a rendering engine and it has a JavaScript engine. And in the browser implementation, it'll create a document object and add it to the context. So it's your browser that provides this object to the context. So just kind of try to keep that image in mind. Actually, so what happens with web workers is they have their own stack and heap, meaning they're running their own isolate, so they have their own memory space. They run in their own threads because, like I said earlier, only one thread can access an isolate at a time. Now, if you think about it, if you have two isolates and you have one object in one isolate and you have another object in another isolate, and they're both running in separate threads and they're basically running in different VM instances and have their own context, they can't really share objects. They can't, if you declare a variable x in one context or isolate, you cannot access it from another isolate. The second one has no relationship with the first one, is not aware of what's being created in the first one, and they basically can't communicate directly. So web workers run in their own threads, they have their own context. They can communicate with their parents, but they cannot share memory, as I just said. They're completely isolated. But they can post through some mechanisms that browsers provide, they can post messages to each other. And there are different kinds of web workers, but we're only going to cover the traditional web workers for browser support reasons. Chrome and Firefox do provide others like service workers, for example, and those are usually used when you want to continuously pull like a backend API for some sort of notifications or messaging for your users. But you can do the same thing with web workers. Let's look at browser support with web workers. I know 9 and 10 are not here, but 10, so 8 and 9 don't support web workers, 10 and 11 do. And pretty much all the other browsers, except for apparently Opera Mini, but I don't think that's the case any longer. I think recent versions of Opera Mini do support web workers. So you, whether you're developing a web application for that's targeting mobile devices, there's not much of a browser support concern nowadays with web workers. Web workers came out with, the HTML5 standard, so they've been around for a while, but not too many people have used them. But you always see questions online. Does JavaScript support multi-threading? In the context of no, people will say, yeah, you have a cluster live package that you can use. But no, yes, JavaScript, you can multi-thread with JavaScript, especially in the front end, where it can be needed the most. Because you'll have your main thread that's updating the UI and dealing with all that. And then you're downloading huge amounts of data and you've got to do some processing because you want to display it on the table and you've got to do some filtering on it. And then suddenly your UI's performance starts getting laggy, the user's clicking away on a button, why isn't this working, and just there's chaos. So you could definitely use multi-threading to your advantage or web workers to your advantage. So here's a couple of features or objects that are available to web workers. You get access to the navigator object, the location object, and of course XML HTTP request object to make your AJAX requests. Set timeout and all that. And what you don't have access to is the DOM, because that is running on your main thread. The main thread is is also sometimes called a UI thread. And only that thread has exclusive access to UI elements. The DOM is not thread safe. You cannot have another thread come along and try to modify areas, memory locations. Since it's not thread safe, it's going to cause a lot of problems that we covered earlier. So it's not a simple matter of, yeah, let's just make browsers multi-threaded. There's a lot of concerns that come along with it. Again, you don't have access to any UI-related stuff, if you notice. So window, document, and parent. So no UI-related stuff. But you have access to XML HTTP requests. So you can make AJAX requests. You can get the data. You can process. You can do some heavy lifting on it. And then post messages to the main thread. And when you're posting a message between your main thread and your web workers, what you're actually doing in most cases is you're making a copy of that. So it's not, when you're posting, let's say, an array of users, in our previous example, to the main thread, you're not sharing its memory location. You're actually giving it a copy. So keep that in mind when you're transferring large objects between threads. A copy is being made, and there's some overhead that goes along with that. So let's go through some code examples. And the first example is we're going to do a simple hello world with web workers. Make this bigger. Is that big enough? That's good. All right. So we have a simple React application. Don't worry if you're not familiar with React. Don't worry too much about the details of it. We'll try to focus more on the pure JavaScript side. So first, we're simply going to post a message. We're going to create a web worker, which is going to start a new thread, and we're going to post a message to it. And the web worker is going to receive this message and respond to it. So just a simple hello world. We're going to define a message. Hello, you there? And we're going to skip the state part, and we're going to create a class called index, which is going to be our main application. And we're going to create a member variable. We're going to call it worker, and we're going to create a function, a callback function, that's going to get triggered every time our web worker sends us a message. And we're going to have another function called start. As you've seen, we set this.worker to null. In start, we're going to instantiate it. And this is how you create a web worker. Very straightforward. New worker. And you can pass it a URL. So we're passing it a file called hello service. If we take a look at hello service, it's very straightforward. You remember earlier you don't have access to window. So what you do have access to, or when you want to reference the worker itself, from then use keyword self. So self, not window, self.addEventListener message. We're going to give it an arrow function, and it's going to post a message back to the main thread, and it's going to respond with hello world. So it doesn't care what it gets, it's just going to simply respond with hello world. The next thing we're going to do after we instantiate it is we're going to add a event listener called message, and we are going to provide it with our callback. Now, skipping the React part, what's going to happen is we're just going to list out the messages in the UI. That's all we're going to do. So let's give this a spin. place some breakpoints here. All right. All right, so this is our application. Nope, it's not. Okay, I tried. I'm new to OS. So here's our little button. When we hit start, it's going to start the thread and execute the code that we started. And then my breakpoints hit. Right. And leave. So I actually have to close Chrome and restart it. Is that?
Yeah, you could just hop back into the Hangout when you're done. I'll just copy that.
Why now? This was working fine 2 hours ago. Okay, there we go. So if you're curious, I'm using Visual Studio Code, and I'm using an extension called Debugger for Chrome. It's really neat. You can basically just set breakpoints in your editor.
Would you mind popping back into that Hangout?
Oh yeah.
Just so we can show your screen.
Let me see if I can use a different product. Do I just double click this? Or?
I think so.
Stand by. I totally forgot I was going to use Chrome.
Oh, there you go.
And discover.
Cool, thanks.
Awesome. All right. Now I can debug and screen share. All right. So where's your application? Here we go. And what we're going to do is we're going to hit start. And we get a breakpoint that hits. Let me just go away. And as we can see, worker is null. And we're going to do some step-by-step debugging. Let's take a look at worker. So we can see that its prototype is of worker. And it has a on-message and on-error property. And we're going to attach ourselves to the message property. And we can skip this part. There we go. And as soon as we ran, we got a response back from our worker. The type of the event is a message event. And the payload is in data. So e.data gets me the message that the web worker sent me. And we're just gonna, we'll skip the React parts, and we're just gonna render. And so that's pretty much it. Very straightforward to use. So that's Hello World. The next example, so if you notice, I had to have a separate file for my web worker. I could just say, hey, here's a function, go run this function. I have to provide it with a separate file. And that's not fun. What if I just wanted a single module, an entire application function there, and not have to deal with multiple files? So in the next example, we're going to take a look at BlobURLs. Let's see. So in the next example, we're gonna do the same thing, but we're gonna use BlobURLs. Now it's the exact same function, but what I've done is I've created exact same concept. We post a message, we get a message back. But what we're gonna do is we're gonna create a function called hello service. And inside this function, we're gonna put the code that you saw was, in the previous example was in our web worker. And we're going to do the same thing. This.worker is equal to null. We're going to instantiate some stuff, bind some functions, have a callback function that receives data from the worker. But in our start, we're going to do something different. We're going to declare a variable called blob content. And we're going to use string interpolation to basically take hello service, and we're going to call it .toString method. And we're going to take a look at what that does. So if you take a function prototype and you call .toString, what does that do? And then we call our function. And we use this URL object, URL.createObjectURL, new blob, and we give it our blob content in an array, and we specify the type. So this is a text JavaScript. Now when we create our web worker, instead of giving it a URL to some file on our server, we're going to give it this blob URL, and do the typical stuff. We're going to add a message handler and point it to our callback. So let's see what happens when we run this. Nope. All right, so same thing, we have a little start button, and we should see hello world. So let's see what happens. Let's take a look, and let's see. So we know hello world is a function, all right. And we kind of want to see what happens if you call string. And so you'll notice when we call function.toString, we get back the
function definition, we get the code of the function. So what if basically what we're going to do is we're going to take this code, we're going to create a blob, we're going to create an object URL out of this blob, which are some built-in features in modern browsers that you can use. I think even 99 supports BlobURLs, although there is a limit on the size of them. So all right, let's to the next step. So we have our blob content, great, and we're going to create this URL. Let's take a peek at what this looks like. So that's what the blob URL looks like. And what if, let's see, what happens if I actually just go straight to this URL? So let's copy this, see what happens. I'll copy this, and we're gonna. What's cool is Chrome also tells you which debugger has caused it to pause. So it's pause in Visual Studio Code. All right. And when we go to the BlobURL, we basically see the text that we sent it. You can do this with images. You can do this with anything, pretty much. So great. So we have a URL that we kind of an official endpoint that we created, and we're going to instantiate a worker, a web worker, and give it this artificial URL that we created. Nope, wrong key. There we go. All right. So great, that worked. We were able to create a worker, a web worker. And we're going to go ahead and attach our event handlers and see what happens. So our main thread posted a message, hello, are you there? And we got a reply back from our web worker. So that's cool, very basic examples. The next and final example that we're going to cover is as close to a real world scenario that I could get to. So let's pretend we're all part of a new startup and we're on a very tight budget. We have $10, and $5 of that went to DigitalOcean for VPS, and $5 is going to go to marketing or something. And you know, the idea of this startup is people can upload their files. They can drag and drop multiple files, and they can share them with their friends, right? Great. And we're going to be a success, and we're all going to be millionaires. So, great. But the problem is our $5 DigitalOcean instance can't handle all the traffic that we're getting. What we do is once we get these files, we're going to zip them and put them in storage, and some sort of file storage, and then link them. We just don't have the bandwidth, we don't have processing power, and you know, things are not looking good. And on top of that, product comes along and says, we want some animations on the bottom. That's totally going to make this success. So we've got some issues, and we're going to use engineering to keep them. Our startup is called Uploadtastic, and we're going to go here. All right. So let's take a quick look at our server. Let's skip the Webpack stuff. Oh, right.
Thank you.
There we go. We have an Express server, and we have a very simple API. We have one method on it called upload. we're basically going to take whatever we get from the client and we're going to store it in a zip file. And then later on, some other service comes along, picks it up, and creates links for it or something. Let's take a look at the front end. Actually, let's. So in our first version of it, we didn't know how it worked. It's been around, we kind of part of the name, but we've never really used it because JavaScript's not multi-threaded, right? It's a very simple application or web application. There's going to be a box, and you can the users can drag and drop files into it. So let's start this up. Oh, right, and the little animation of how that's requested. All right. So we're going to start our server. And all right, so here's our website with the animations that product requested. It's very important for sales. And so what we're basically doing here is, if we take a look at the React code or the JavaScript, we have a function called move lightning. And this function basically just, document.getElementById gets the lightning image box and just rotates it. So in our main thread, we're constantly doing UI updates. We're constantly moving this around. Well, what if we start doing other stuff? What if we're, uploading files? What's going to happen? So one of the things we want to do, because we were on a budget, is we want to leverage client-side processing. So we want whatever the user drags in here, we want to zip it. We want to compress it on the client side because we just don't have the CPU and then we can handle all that. And we're not going to scale well if we do all that. So our little tiny server can't handle that kind of traffic. So we're going to rely on our users who have nice i7, i5 processors and 16 gigs of RAM. I'm sure they can handle doing some compression for us and just send us a file. So let's see what happens once we let's drag some files in here and see what happens. So I'm going to drag my very important file, lots of stuff, not data, and it's 100 MB. And I'm going to drag and drop one file. And suddenly, animation stopped. Okay. So it stopped for a second, but we did receive our zip file. So that's great. So what just happened is, as soon as I drag and drop the file onto the box, we zip the file, and then we make a AJAX post request from our node server, and the node server receives a stream and pipes it to the local file system. So that wasn't a lot of fun with just one file, and it's starting to affect the users. But now, we're getting more popular. We have more users come along, and a lot of these people are uploading, very large files. So here's 5 files, and by the live application. So now the users are like, oh my god, the Thunder animation stopped. I don't want to use this website anymore. It's just not good enough. What can we do? Well, we can multi-thread all the heavy processing. So let's see an example of that. Let me show you, I guess I can show some of the code here. So very simple, I'm using a NPM package called JSZip that's going to handle this for us. And I have a React component called drop zone, and that lets me create an area for drag drop, so I don't have to worry about it. So it gives me a list of files. I take those files, and for each file, I'm going to zip it, and I'm going to create a blob, and I'm going to use deflate for my compression algorithm, and then I'm just going to post it to that URL that we saw. So very straightforward. Now let's look at same thing with web workers. So same thing, but in this case, instead of doing all that processing on the main application thread, what we're going to do is on drop, when we receive the files, we are going to create a web worker, and we are going to post that files to the web worker. And the web worker, let's take a look at the web worker real quick. So the web worker is listening for a message. When it gets that message, it goes, great, I received some files, and it imports JSIP. It takes those files, and it's going to do all the heavy lifting for us. It's going to do all this compression and posting and everything in a separate thread while we're busy animating our Thunderbolt. And so let's see that in action. So first, let's try it with one file. And everything's fine. Thunderbolt doesn't stop at all. Okay. Let's select a couple of more files. Oh, actually, oops. And let's drag and drop a bunch of files. So this is the node part of it. But the most important thing, the Thunderbolt is still up, and there it goes, and our animation didn't stop, and the users love our site, and everybody's happy, and we're millionaires, right? And that's how web workers save the day. So that's all I have for you guys. I will post a link to upload Tastic on GitHub. It's actually already on there. I will post it on the GitHub so you guys can check it out. All right. So any questions, thoughts? What would you guys use web workers for? You see any use case for it? Yeah, pretty heavy. No, nice, yeah. And then you have your animated Thunderbolts.
Yeah.
Nice.
We know there's ways for request animation here.
So no UI stuff. That's exclusively.
So that's specifically what I don't know where that fits in. So because I mean, it's setting for all, and the other one are not supported. I don't know why. I mean, I don't know.
I would. So I haven't worked a lot too much with request animation frame, but I would assume any UI directly any UI related stuff, you're not going to be able to directly manipulate it from the web worker itself. You would ideally just use web workers for heavy processing calls that you know are going to be blocking. Do all that in web workers.
I mean, it's like setting your log, whenever you have your certain setting your log, whatever function you call, it has to be exclusive to that web worker. So you can't communicate with each other.
Yeah, it's not just trying to animate the thing.
No. So what's happening is I'm freeing up my main thread to do the animation. so that we moved all the heavy processing to the web worker. Initially, I had all the heavy processing and animation happening in the main thread. So here, let's take a look. So in the first example, we have move lightning, and we have a timer that's calling it every 100 milliseconds. So this function is, it's manipulating the UI. It's doing, it's moving stuff, and then when a user comes along and drags and drops some files in there, well, now your main thread is busy doing the compression. And so, when the timer interval comes and your millisecond says, hey, I need you to move the files, the main thread's not paying attention. It's busy compressing files and then uploading them. So that's where you see that pause happen. The main thread's busy doing compression. So what we did was, on drop, we take those files and we post them to the web worker who's running its own separate thread. Hey, you take these files, you do the compression, you do all the stuff. I'm busy moving to Thunderbolt because it's helping sales.
You said earlier that the web worker can post a message back to the parent thread to do something for it, right?
Yes.
So communication too. You're doing like something like, suppose you have like you're doing matrix calculations, in these cases, that's heavy work to do that, and you want to do that on the thread, but then you want to draw the result, main thread, you can post back the result of the calculation, and you're done with it.
Exactly.
Then I'm still drawing the main thread. There's a chance that work will be done around that and get off over the way.
Right. So that's a perfect case for, if you have a graphics intent application, 3D animation, and all that. Do all your calculations in the web and post the results of those calculations back to the main thread. And all the main thread has to do is draw, animate, just deal with the UI.
Like your game doesn't slow down.
Right, exactly.
Yeah, let's say you had a lot of matrix work to be done that was parallelizable. Is there a way to break the matrix and finish it different workers, have shared memories and copying into each of the workers' memory?
Shared memory? So you mean like you have multiple web workers and they're all posting messages to the main thread, or we're trying to communicate with each other?
Ideally, they wouldn't have to communicate with each other, but so, like, we have a big matrix to try and work on in a separable way. Can you avoid copying this matrix to each worker and just all work on the same?
You'd have to split the workload. You can't have web workers do have this one concept, which unfortunately doesn't solve the problem situation. But there's this concept of transferable objects. And so how I mentioned, you're posting a message, creating a copy of it, and then the browser takes care of, let me give this to the other thread. But it's a copy, and a copy can has an overhead. So you can use transferable, like typed arrays, for example. Certain types are transferable. In my case, file transferable. But what happens is you have that memory location isolate. And once you post it, it's transferable. I can show the next. It actually disconnects that from the first isolation, provides into the second isolation. So what happens when one thread or one web worker transfers, for example, this typed word, it gets zeroed out in the sender context, and then it appears in the destination, and that's much faster. So that's one way you can kind of get around it. But you would have to have processing multiple web workers. You would have to have a way to split your load. So for example, here if I wanted my file up to be I could create two web workers that are my compressors and upload pages. I have a service called compress and upload. And if I get 6 files, I'd say half of those send to the upload worker. the other half to another, and they'll be done.
Transfer message and transfer the ownership still can't transfer the sharing.
No,
With the what?
right, yeah. And then that gets to, so I guess I would say the advantage of JavaScript, you don't have to deal with logs and worry about using memory and, all the problems that come with it. It does have a decent degree of memory, but it also, compared to C, I think pretty much every thing had a disadvantage to C besides development time, right? Because you can you have complete overlaps, so you can't do that. You cannot.
So all this is happening in the browser?
Yes.
Okay, so are there compatibility issues in the way different browsers handle the web or the data that they're
If you start getting some more specialized workers, you're only going to be able to Chrome, Firefox, Safari. But there's multiple browser support isn't great out of the if you're using BlobURLs, you have issues with 99. You have a limit on the size and the size. Cool. Any other questions? You all ready to use web workers?
It's an language in a way that there's still a lot on actually execute instructions. So you could each actually get transfer and it's still
Definitely walk over.
So yeah, that execute two workers. Yeah, so I think they're sort of at the same time. It wouldn't actually be faster than doing one worker sequentially. So do you know how that applies here?
So, I mean, you're talking about accessing the same memory location?
No, I was talking about it itself. So like, I was seeing in V8 session, when you create multiple JavaScript threads, it actually creates, it does in a way that multi-thread on a local machine too. So you do get that there. It's not like taking it out, switching between them around rather than training line. We're actually probably on the client side.
Yeah, they're actually they're getting over here.
That's the point is.
Right. And you can have a little bit of
Let's say you want to put a progress bar, you know, that kind of thing. You
Sure.
send messages back to the carrier or something. Is that
Well, I mean, if you're only sending back the percentage, that's, yeah. I mean, I didn't mean to scare you in terms of overhead costs. I mean, I'm talking like if you have an array of, let's say you have a sales table, you're generating a sales table, and you have all the sales records and object literals and array, and you have like 200,000. Please do not post that that array of 200,000 elements back and forth. You could if you wanted to, if you're a rebel, but. Right. So instead, in that scenario, what you would do is you would have, so you have a paginated table. Have your web worker, which is kind of like your data service. Once they get to there, have to filter the paginate on its thread and post the paginated results back. And then you let her just split that. And then when the user clicks on page 2, it's enough. You post a message from your main thread to the web worker and say, "Hey, give me page 2," and it's pagination.
so you're looking at the
Exactly.
Can you transfer something to memory back to the parent?
When you say
So like when I can transfer something, parent ownership to memory, whether I transfer to the parent, so it goes back.
so you want to have
You can have the data array of orders saying, instead of posting that back
There are only specific types of elements in transferable objects.
Right. Suppose it was transferred,
Sure. Yeah, that would be much faster. So if you had an array of 2 billion integers and it's in a type array, that's a type transferable object. So you can actually safely, with no overhead, transfer it to back and forth. Because all that's happening is moving the reference from the first isolate and pointing to the second isolate. So yeah, so that's so there's some little tricks you can do if you are dealing with large amounts of data. But when you start using WebWorkers, you'll be it's great compared to just doing the same thing that we've been doing in Thread. That's awesome.
In that example, like a little bit for the worker, can there be problems if the different worker was working on that array?
Well, they can't. They can't access the same array. When you create, large users, 100,000, first thread, in my main thread, when I create a new web worker, that web worker doesn't have access to this variable. There has to be some posting that the one thread has to explicitly post data in order to give it to another user.
Probably the transfer concept is going, so you can't say what and still be
right.
happens like intact.
So
I guess in the less greater than it
let's see.
Yeah,
So if we right. So each thread has this setup. When you create an array, it's living in this box right here. And then you create a new web worker, you basically get the same thing and it's running a different, same setup. And that array is exclusively living in that box. As the name of the object, isolated. It's isolated. Nothing else can just come in. Hey, can I also read this while you're here? You can't. Only one thread can access isolated. But you can transfer, you can post messages back. And you're transferring, what happens is it says, okay, this isolate no longer has this array, and now this other isolate has this array. Okay, so this first guy loses access to that once you transfer it.
If you try to access it, it's just
but this is with transferable objects. Right? So when I'm in this code example, there's a very specific type of objects in JavaScript called transferable objects. And so that disconnection happens with transferable objects. There's a limited set of objects that are transferable, one of them being typed arrays. But so for example, here,
if he was asking about the local variable reference, will that just become null and the transfer over?
Yeah, it gets zeroed out, right?
Undefined.
Right. So if you have an array of 10 items and it gets transferred, that array length becomes 0.
Okay, awesome.
Yeah. Well, but if I'm posting a message, a copy of this is being made. So this initial thread on draw still has access to files. Nothing has changed. But if the file blobs were a transferable object, and I basically the syntax for it is like this. So if I had done this, file were transferable. When I log this, basically files will be an empty array. That context has lost access to it.
Copying.
But it's not cost by value though. Isn't it to transfer the reference?
So when you're using transferable objects, that's by reference. But when you're just posting messages, for example, this is by value. So this is by value.
And if my files was a typed array, and I did this, and I used this overload of post message, then that would be by reference.
Files and array with new memory with 0.
Files gets zeroed out on the initial thread, and only the web worker has access to
That's you primarily do that to
large objects.
How many minutes can you pay for?
So
web workers are really, really expensive. It can be, because if you think about it, every time a web worker is created, you have, the handle scopes in our, let's see, so you have, an isolate that's created. You have local handles. You have the handle scope. You have context. You have all these objects that have very heavy functionality that are created. Of course, I'm exaggerating a little bit, but Chrome does take some advantage to optimize the global objects, the copy of the global object that it does have some tricks up its sleeve. That hard. But the Safari does the same thing. I'm not sure. Right.
There's no very loading the other stacks and overhead.
So remember, every
thread does come with one stack traditionally, but in this case, not only is it coming with one stack heap, it's coming with some copies of BlobURLs and handle scopes. And, so you get it's pretty expensive. Right. Yeah, almost. Technically, I'd say it's a VM instance, but there's still the same engine that's handling that. Right. Yeah. I mean, C or .NET, C#, or whatever. I'm sure in Python, those are much lighter. But, hey, at least we have everything.
Yes. So, if you have two different browsers running the same program, is it predictable the way that they'll behave? For example, like let's say the time, let's say on the main thread you're waiting for something to come back from a web worker. Is that result going to be the same on Safari as it is on Chrome, or is it somewhat unpredictable because the timing of the different threads are going to be different?
So you can expect the same results. There's no differences in how different browsers are, basically what input and output you get using web workers from Chrome will be the same in any browser that supports the web API, the web worker standard. But if you're, I wouldn't rely on timing events or at least personally, I would only use them for, like I said, heavy data processing. Or maybe even pulling, back on that. Hey, get messages. Oh, there's a message posted to you over a cool chat that pops up. Hey, you have a message. That sort of stuff.
I think you have to use the synchronization of the techniques.
Yeah. Right. Right. If you have some kind of critical stuff, like I need this to happen, this message will be posted in 10 milliseconds, and that wouldn't be an optimal use case. Right. It's there's real-time processing field, real-time processing operating system. I wouldn't trust like they get a response back like
send a message to the response from the I think we would expect the same result from Safari. Is that
Fairly abstract. I'm not even sure why I asked the question, but it was.
No, I mean, it's a good Yes. Yeah. API has standardized. This came out with version 5, so it's been a while. But yeah, for some reason, many people have become very popular. But you always see, if you open developer tools in any Google site, I guarantee you'll see. I don't know if you noticed. Here, let's see. Variety was the service this is offline, but you have information that is cached, and once you come online, I'm going to go get that. Right. And they recommend using service workers for providing offline availability. This is. So if I reload this, good. Huh. Yeah, I thought there was a little gear icon. Oh, there you go. So you'll see. And it's gone. But you'll see that pretty much all those area developer tools if you get a majority of Google sites. Yeah. Cool.
Remember that I had things that we did the main investigation tool that I was doing conceptually using timing for playing music.
Yeah.
When I if the tab is inactive, then the every time off. But if I use the work timing, then you could window or tab and still put messages on this.
Right, yeah. Oh, so there's timing there. All right. I think that's pretty much it. Any other questions? All right.